Good morning, everybody. I am S. Gopinath. I am working as assistant professor in Information Technology Department in V.S.B. Engineering College, Karur. Now, I handle the class for the topics data structures, a comprehensive guide. Actually, what is data structure? How the computer data is organized and stored in the computer's memory. In this regarding, we study the data structure concept. We simply tell data structures are fundamental to computer science. They are essential for organizing data efficiently. This presentation provides an introduction to various data structures, highlighting their characteristics, advantages, and disadvantages. Okay. Next, we see that in the data structure topic, we see that one subtopic, arrays. What is arrays? Arrays is the sequential memory. Actually, in this topic, we see the sub-contents, sequential memory, fixed size, applications, examples. What is sequential memory? The arrays stored elements in contiguous memory locations, allowing for efficient access and traversal. The array contains the memory size, the fixed size. Once it is created, the size of an array is fixed. Dynamic resizing is if needed. The applications of the arrays are used for various purposes. Example, storing lists, matrix, and other data collections. The examples of the arrays are database, spreadsheets, and image processing. Next, in data structure topic, we see the sub-content linked list. In linked list, we see the some contents, dynamic memory location, nodes, the operations, and the applications. In dynamic memory locations, the linked list allocate the memory dynamically and allowing for flexible size adjustments. In nodes, elements in a linked list are stored in nodes, each containing data and a reference to the next node. The operations of the linked list include insertion, deletion, searching, and traversal. Okay, it is very important point. What are the operations of the linked list? First one is the insertion, deletion, searching, and traversal. Last one, the application of the linked list are we say some examples: stacks, queues, and host tables. Then in data structure, we see the subtopics: stacks. What is stacks? Last in, first out structure. In the subtopic stacks, we see the subtopics: last in, first out structure, and the operations and the applications. In last in, first out structure, the stacks follow the last in, first out principle, where the last element added is the first to be the removed. The operations of the common stack operations: push and pop and pick. Push means adding an element, and pop means removing an element, and pick means accessing the top element. The application of the stacks are the function call management, undo redo the functionality, and the expression evaluation. Next one, in data structure we see the subtopic queues. In queues we see the subtopics: first in, first out structure, operations, and applications. In first in, first out structure, the queues follow the first in, first out principle, where the first element added to the first to be removed. The operations of the queues are NQ, DQ, and pick. NQ means adding the element, DQ means removing an element, and pick means accessing the front element. Next one, the subtopic in the queues. The queues are in various applications such as task scheduling, print queue management, and and message queuing systems. Next, in data assets topic, we see the subtopic trees. In tree, we see the subtopic the trees, the hierarchy structure and types and applications and advantages. Actually, basically, the tree represents a hierarchical structure with a root node and branches leading to child nodes. The types of the trees are binary tree, binary search tree, and AVL tree. The applications of the trees are file systems, database, and search algorithm. The advantages of the trees are insertion. It is used to efficient search, insertion, deletion operations, and especially for large data sets. In data structure subtopics, graphs. In graphs, we represent the nodes as the vertex and the edges as we represent the connection between the vertex. The nodes are classified into directed nodes and undirected nodes. In edges, we classify into weighted nodes, weighted edges, and unweighted edges. And the application of the nodes, social networks, maps, transportation systems. And the edges are used to finding shortest paths, network routing, and data analysis. Next one, in data structure, we see the subtopic heaps. The heaps contains some subtopic periodic queue, binary heap, tree structure, applications. In heaps are used as the periodic queues, allowing for efficient retrieval for the maximum or minimum element. The binary heap is a common type of heap where the parent node is always greater than or equal to its children. The tree structure. In tree structure, heaps are based on a tree structure with specific ordering rules and applied to the nodes. The application of the heaps are Dijkstra's algorithm and Huffman coding. Next, in data structure, we see a subtopic hash tables. In hash table subtopics, key value pairs, hash function, collision handling, applications. Actually, in key value pairs, hash table stores the key value pairs, allowing for efficient retrieval using the key. The hash function maps to key indices the hash table, minimizing collisions and ensuring fast access. Actually, in collision handling, it is represented as the separate chaining and open addressing. The application of the hash tables, database, cache, and symbol tables. We see the examples for this example for the hash table. It contains John Smith and Lisa Smith and Sandra D. It is the keys. His hash function is mapped to in the bucket form. Okay. This example is illustrated the hash table functions. It is the final subtopic, conclusion and applications. Actually, data structures are essential for efficient data management in various applications. They provide framework for organizing, storing, and manipulating data, enabling efficient algorithms and improved performance. From database and web applications to search engines and artificial intelligence, understanding and applying data structure is critical for developing robust and scalable systems. Thank you.